Okay, so over here we're given this right triangle and we're asked to find secant of theta. Now secant of theta is something that you're just going to have to memorize or know. So if you search it up online, secant of theta is equal to 1 over cosine of theta. Now you might be like, okay, well then what's cosine? Well, I can't tell you how to easily remember secant and cosecant and the other one, whatever it is, but I can show you a mnemonic device that my geometry teacher showed me my sophomore year of high school to remember what sine, cosine, and tangent are. So it's sa, ka, toa. So it sounds like suckato, which is the whole reason why you remember it, because it sounds so weird. I know it's weird, but that's how you remember it. So S, right, stands for sine, then we have cosine, and then we have tangent. And then it just tells you the fractions that you have to use. So O over H is equal to sine of theta. Then you have A over H, right? And then you have O over H is equal to tangent of theta. And also know that when I'm referencing to theta, I'm referencing to an angle. So theta means an angle. That's the angle that we're trying to find here. This is the angle over here. O stands for opposite, A stands for adjacent, and the H stands for hypotenuse. So now that you know what cosine is, which is over here, this is our formula, you can just plug that in over here. So it's going to be 1 over A over H. Now we need to find the values at this point. We do know what H is because if you look at the right triangle over here, anything across from the right angle is H. Anything opposite from the angle that we're trying to find is O for opposite, and then anything left is A. So we do know what H is. It's 8. So let me just plug those numbers in already. But then we don't know what A is. But luckily for us, we have something called the Pythagorean Theorem, which is a squared plus b squared is equal to c squared. Now c squared is going to be your hypotenuse, so that's going to be 8. Just plug that in. B is going to be whatever I have left with, which is just 5. So plug that in. And then I'll just put my A value, which is basically what I need to find, right? So I'll just simplify. So a squared plus 25 is equal to 64. You do minus 25 to try to solve for A. You're left with A squared is equal to 39. And then you want to get A alone. So to undo a square, you have to square root. So you're left with A is equal to the square root of 39. So then you can plug that answer over here. Okay, and now you're left with this weird looking function that you actually have to simplify. You can't leave it like this. So first things first, I never like fractions in the denominator. So what do I do to cancel out a fraction in a denominator, right? I multiply by its reciprocal. So I know, let me use a different color. What color? Should I do blue? Maybe I should do blue. Okay. Multiply by its reciprocal. So the reciprocal of the square root of 39 over 8 is actually 8 over the square root of 39. But here's a little problem. We can never have a square root in the denominator. Therefore, this can't happen. So we have to simplify this before we use this to cancel out. Because usually, you would do it on both sides. So 8 over the square root of 39. But you can't do that because you can't have a square root in the denominator. That's a no-no. So before multiplying by its reciprocal on the numerator side, we have to simplify this. So in this case, let me switch to another color. Let's do this one. This is called rationalizing the denominator. So what you want to do is you want to multiply right over here by the square root of 39 and then do the same thing on the top. Now, here's how this works. When you have two square roots together, it's the same as saying 39 squared. It's literally saying, you're literally multiplying, right? It's doing 39 times 39. Okay, that's the same thing as 39 squared because it's 39 two times, right? So knowing that, you have it this way. You don't want to solve for it. You just want to get it to be simplified as best as you can without getting into decimals. So if you know this, if you have it set it up as 39 squared or whatever number you have in there squared, in any other case, you know that a square root cancels out a square. just know that the square root and a square are inverse operations of each other. And we saw that over here, right? When we went to cancel out the square, we had to square root because these two cancel each other out, right? So they're inverse operations of each other. And when we do that, we're left with just 39 because the square root and the square canceled each other out. So we're just left with 39. So now, let me move to the side. Okay, so now, what happened? Okay, there we go. So now we're left with just 39 for the denominator. And over here, we multiply these two numbers together, which is just 8 over the square root of 39. And now we can actually cancel out. So these two things, so this one thing and this one thing over here, they cancel out. But then you have to do multiply, do the same thing on the top. So if you multiplied by the bottom, you have to multiply by the same thing at the top. And so now, because this canceled out and this canceled out together, we're left with 1 in the denominator. We're left with 1 in the denominator. And then because we multiplied by this, by the reciprocal of this, of square root of 39 over 8, we multiplied the reciprocal of that to the numerator. We're left with, let me clean up everything real quick. Oops. So these cancel out, and we're left with 8 over the square root of 39 over 1, which is the same thing as 8 over the square root of 39 over 39, and that is your answer. Hopefully that cleared things up for you. So yeah, secant, we want to write it, secant of theta of this angle, the secant of this angle is 8 over the square root of 39 over 39. And that is your final answer.